Hello members, in this lecture we are going to discuss sample and population. So we are going to be looking at the formulae that we use to calculate for sample mean, population mean, sample variation, uh, sample variance, population variance, standard deviation for the sample and for the population. Now, why do we need to know these formulae? Because they are going to be important while performing various statistical calculations, including hypothesis testing and confidence intervals plus regression. So now, in hypothesis testing, you will be looking at, for example, the height of different people, which could be females and males. And then maybe, according to your analysis, or according to your observation, you say that males are taller than females. So if they are taller than females, then that means the average height of the males is greater than the average height for females. So that would be your hypothesis, and you go ahead to test it. So you'll be having a null hypothesis and you have the alternative hypothesis, of which will require you to get a sample from the population and then carry out the analysis on that population and make a decision on the whole population. Because usually it is difficult for you to get all the data or to carry out all that analysis on the whole population. So you pick a sample and do the statistical analysis on that sample, and then make a decision on the whole population. So some of the parameters that we need to look at include the mean, and the mean population mu is going to always be the sum of the data points or data values divided by the total number of the values. So if you have, for example, heights, you could be having heights from 1, 2, 3, 4, 5, 6 up to 7, then divided by the number of data points, which could be 7. Another one can say if you had, for example, frequency, that nu would be sum of fx divided by sum of f. So this is the same as what we have just said. What about the sample mean? Sample mean can also be adding up the data points of course, in the sample, then divided by their number, and then you'll be able to get mean. If they have frequency, also sample mean can be sum of fx divided by sum of f. Whereby f is the frequency, of course, and x represents each individual data point. So what about variance? We need to look at the population variance represented by sigma squared. This is equal to the difference between each data point and the mean of the sample, I mean of the population. Then squared, then the whole thing, after I have summed those values, I divide by the total number of the values in the population, or the total frequency of the population. So that is how we can get variance. And then the sample variance is a little bit different. You get that value, each individual value, subtract the mean of these values, then you square, of course, as we have already said up there, but then you divide by n minus 1, whereby n is the number of observations, okay, in the sample. Okay, so that's how you can get the sample variance. Now the standard deviation is always equal to the square root of variance, is equal to the square root of variance. So I just take the square root of that value, and then I will get the standard deviation. The same as sample standard deviation, which will be represented by S. The variance was sigma squared, then the standard deviation is sigma for population, But for standard deviation of the sample, then it will be represented by S. And then taking the square root of the above formula for variance, I will be able to get the square root of S squared, and then I will have calculated the standard deviation of the sample. So what about the z-score? The z-score for a population is x minus nu divided by uh, standard deviation, of course, of the population. Then the sample z-score is x, which is the individual value minus the mean of the sample values divided by the sample standard deviation. Now, what if we are testing hypothesis? If we are testing hypothesis, your z-score is going to be x bar, which is the mean, of course, of the population, then minus the hypothesized mean. Because here we could be testing hypothesis about mean of the population. And then we find that we are testing that either mean is equal to 0 or mean is not equal to 0. Sometimes we are testing that mean is above a particular value or is less than a particular value, and then we go ahead to decide on what that mean is and what it means if it is like that for the whole population. So these are the formulas we need to use. For z, it is x bar minus mu divided by sigma divided by root of n. This is what we call standard error. Okay, so if they asked you standard error, it will be that standard deviation divided by the square root of n. Okay, and of course, this is the value of n, the number of observations. Okay. So what about if we are talking about the sample? This is the z-score for the sample, whereby this is going to be the sample mean, and this is going to be the hypothesized mean divided by the sample standard deviation divided by root of n, whereby n is the number of observations. So members, that's what we can do in this lecture. So whenever you asked, for example, standard deviation given a sample, you should be able to know how to calculate it.